We're going to go ahead and get started. This is session D09, Theory to Practice, HADR in the Real World. So we're going to start out with some details of HADR and some of the ways that it works. Go through a few tools that are useful when working with HADR and getting into some of the details of it. And my clicker has ceased to function. There we go, agenda. And go through and get into some things I've run into in the real world. My name is Ember Crooks. I'm an IBM Gold Consultant and IBM Champion. I blog at datageek.blog on a lot of topics. I have over 500 published blog entries at this point on LUW topics. So let's start with going through some of the basics of HADR. The way I start describing HADR when I start talking to somebody about it is HADR is log shipping, but not at the log file level, at a memory level. With HADR, we usually have one primary database server, and then we have one or more standby database servers. Now, one of the standby database servers is referred to as a principal standby, and that principal standby is usually in the same data center. It doesn't always have to be, and is used for high availability purposes. The additional standbys are often DR standbys. They are often in a different data center, and those are used for DR recovery. And one of those servers might be on a time delay. The reason we like a time delay server is so that we can deal with human error. The worst real-world recovery problem I had to deal with last year was in October on a WebSphere Commerce site. One developer tried to go out and change their password by updating the Db2 database directly. They forgot the where clause. They updated the password for every single end user of that website to the same value. Now, the value they used wouldn't have actually worked for anybody because WebSphere Commerce uses a salt. So basically, everybody had to go reset their password in order to access anything. And instead of doing that, obviously, what we ended up doing is we had a 4-server pair like this. We didn't have a time delay. So what we did is we broke out one of the DR servers, extracted the data they needed, and then pulled that back into production. Now, that developer doesn't really work at that company anymore. I'm not entirely sure it was because of this event, but it very well could have been. That client was very upset with that particular scenario. And I've tried to get them to add in a time delay. Even after that issue, I can't convince this client to add one of their servers in as a time delay. So it's one of the things that is on my top list. If you have a bunch of HADR standbys, and especially if you've got 2 in DR, consider putting one of them on a time delay.
How much time delay actually works? It depends on the time of day and everything else.
Yeah, exactly. It depends on how long would it take you to notice that kind of a failure, right? How long would it take you to notice a table was dropped in the wrong environment, or a user forgot a where clause, that sort of thing? You know, sometimes that answer is, well, it would take me 3 weeks. Well, you know, that's not necessarily the kind of thing you can recover from using a time delay. However, if you don't notice it for 3 weeks, then they're probably not going to care if you can't restore it right away as well, right? So it's something to talk about with your business, discuss the kind of issues that you might see, and consider using a time delay on that additional server. Now, any 2-server HADR cluster can only be either high availability or disaster recovery. If you want both high availability and disaster recovery, you need at least 2 standbys in order to serve those purposes. And the main reason there is that for high availability, we need something that is very fast, that we can use a synchronization mode, which we're going to discuss in a minute here, between these 2 servers that is very much up to date. And if we're talking about disaster recovery, we want to have a database server that is far away from our primary database server. The thing that always comes to mind when somebody wants to know the difference between high availability and disaster recovery is when I was discussing it with one client, somebody on the phone asked, well, what if Dallas wasn't there anymore? They meant the city. So it's a matter of a significant outage that you're talking about with disaster recovery. It's not just your common everyday disk failure or even a server failure. In the HADR ecosystem, I really think of it as having three parts. We have HADR, which really is the workhorse of the situation. It keeps data synchronized between the servers, between 2 and 4 servers, and there's nothing shared between those servers in most situations other than, obviously, a network connection. TSAMP is what provides automated failover if you want to automate the failover. If you don't put TSAMP in, then actually failing over, doing a takeover between servers, is done with a takeover command. It's very fast, but it's usually done by a person. If you want to script it, don't script it, use TSAMP or a similar tool in order to do that part for you. Automatic client reroute is awesome. The main role that it provides is when you set it up with HADR and TSAMP, you're actually setting it up with your virtual IP address as the alternate server. And some clients at this point can pull in that alternate address, and what that means is if somebody accidentally or intentionally connected directly to the database server rather than to the virtual IP address, then they might have the virtual IP address stored as an alternate server and be able to get to that server that way. Okay, so availability. This is a question I get a lot. I have clients come to me and they say, Ember, we need active. We absolutely must have 2 databases that we are writing to at the same time. And that conversation always goes into requirements. What are your actual requirements? What is your company's stance behind what you actually need? Because it usually comes down to requirements. The requirements that they have can be met by a different solution. So if we're talking about standard Db2, it's really 1.9 of availability that we can provide with standard Db2. Sometimes we can get close to the 2.9s, but it's really hard to guarantee that when we consider the size of databases and multiple different kinds of failures that can occur. HADR is really great for 2.9s and 3.9s. I've seen it do pretty close to 4.9s, but there are still some scenarios in which it may get over that, and that becomes pure scale or pure scale and replication. And the reason I have replication on the bottom line here is that even with pure scale, you require downtime in order to do a database level upgrade. And database level upgrades, if they're considered in the 9s, some people don't consider them in the 9s because that's a planned outage and they think of the 9s for unplanned outages. If you want to go over the hump of a version level upgrade, replication is the only thing that can keep you up pretty much over that hump. Okay, allowing reads on standby. Now there's some changes to this in recent fix packs and recent versions. You can allow reads on any of those standbys. The primaries in the same data center and the 2 in the other data center as well. It's often not yet suitable for full reporting, and they're working on some of that. So Modpack 4 of 11.1 decreases a lot of the issues with query execution on the standby. So a lot of times queries were executing on the standby, or somebody tries to execute a query on the standby and they get issues. And I have a running HADR environment where I don't tell them, they have enabled reads on standby, and because of licensing, they don't really care in this particular environment. And so I don't really tell them they can connect to the standby. But for really big reports that they want to run during business hours, they know to come to me. And I'll run the SQL on one of the standbys for them so that I can get that without impacting my primary database server as much. Even once we talk about resolving some of the issues with reads on standby, you're still not able to add different indexes on that standby. And if you're talking about a reporting workload, you're usually talking about a very different set of indexes that you want than for an OLTP workload. So for me, that's still a stumbling block. And you also can't do things like create temporary tables. You can't do explains. And non-inline blobs also can't be queried on the standby. So there's some restrictions there. If you're considering reads on standby, make sure you go into the Knowledge Center. There's a link in the student notes. Make sure you go into the Knowledge Center and read through those and what they are for your specific version. Okay, so HADR licensing. Please note this box over here. Verify licensing with IBM. They change it on me all the time. It's different in different regions. So this is what I am aware of, and this is what I believe as of right now, but I'm not 100% on this. So HADR is included in every Db2 edition. Developer C includes it on 11.1. And that's a free version that you can run on up to 4 cores for free, so it's included in every Db2 edition. The primary server is licensed normally, so whatever PVU count, virtual CPU count, whatever metric you're using, you license your primary server normally. And the standbys are considered warm standbys. They're not cold standbys. So I had a client literally yesterday on the phone to me say, oh, I don't need to license my standbys because they're not actively running. As of today, I don't know if this is going to change tomorrow. As of today, you have to license your standbys at 100 PVUs of licensing in order to run your HADR standbys there. And that's if reads on standby, ROS is reads on standby, is not used. If you are trying to do reads on your standby, that server must be licensed just like any other Db2 server. Does that make sense? Okay, the sync modes. Now, this is something that I spend quite a bit of time paying attention to. I've asked Dale McInnes a number of questions on this over the years to make sure I have all the details right. But it's important to understand the synchronization mode that you're working with when you're working with Db2, with HADR. You need to make sure that you think about this not just for your principal standby, but understand what it means for your auxiliary standbys as well. So if we're working with HADR and with Db2 and we don't have HADR, so in this scenario there's no HADR involved, this is just your normal commit processing. You have a commit come in, it comes into Db2. Db2 will write it out write the log buffer out to disk. And that's that's satisfying ACID. That's making sure that you have something that is durable, that will not go away if something happens. And then after it's done that, after it's written out to disk, to the log disk, that commit is considered successful. Notice we're not writing out to the tables. We're not doing anything else. It's that write to the log file that is what satisfies the durability of the ACID requirements. Okay, so now if we have 2 servers with HADR, we have a primary database server over here, and we have a standby database server over here, and we have a commit come in. This is the synchronous mode of Db2 HADR. We have a commit come in to the primary database server. First, the log buffer is sent over into the HADR send buffer over the network to the HADR receive buffer, and written out to the log buffer on the log buffer and out to the log file on the standby database server. And then an acknowledgement is sent back. And finally, that work is also performed on the primary database server. And only then is that commit considered successful. Now notice, in this case, the work is done on the standby first, and then the work is completed on the primary. Now, notice that in the middle of my commit, instead of just having one write to disk here, I have not only sending it to memory, sending it over network, and then writing out to disk on another server, and then sending it back over network the other way. So sync is the mode that is most likely to impact your performance. But with sync, you have it guaranteed that has made it to disk on both database servers. So there is no risk of data loss with sync. Any questions on sync? Okay. Nope, the log buffer, you need to have actually a pretty good sized log buffer. You actually want to make the log buffer large enough. Db2 will take care of writing the log buffer out to disk for you. as part of the commit. Whenever any commit comes in, Db2 writes the log buffer to disk. Okay, so for NEARSYNC, we have a commit come in. It comes into our primary database server, and there's actually some things that are done in parallel with this one. That commit is sent over to the HADR send buffer, across the network to the HADR receive buffer, and then acknowledgement is sent back to the primary at that point. Notice we did not write it actually out to disk on the standby. We just made sure that it's in memory on the standby. And at the same time that is done, the log buffer is written out to disk on the primary. And when both of those things have completed, the commit is considered complete. So the work is done in parallel. We've eliminated the disk on this side, but we still have the network in the middle of our transaction. And that's often one of the slowest parts of this whole scenario is the network. So it's something to keep in mind that both sync and NEARSYNC can impact performance. You want the servers in these cases to be very close to each other with a high-speed network in between them. It does asynchronously, right? It's got a different process that's doing that. It's not something that it's waiting on. So it does get written to the disk, right? It's not that it never writes to the disk. Okay, with async, what happens is we have a commit come in, and Db2 will put that commit into the HADR send buffer on the primary, and it will write it out to disk on the primary, and then it considers the commit successful. So in this case, we have taken the network and the disk out of the middle of this, but we don't have an acknowledgement that as part of the commit, we don't have an acknowledgement that transaction has actually made it to the standby. Okay? So think about what these scenarios mean for data loss, right? In our first scenario, we had no risk of data loss. With NEARSYNC, which was the second mode we talked about, with NEARSYNC, the chance of data loss is if I lose both servers at the same time and I can't get the primary back up. It could be that what was in memory on the standby and hadn't been written to disk yet is what would be lost. So think about the scenarios that you're trying to protect against when you're deciding what synchronization mode makes sense for you. The most common one that I see is NEARSYNC, mostly because it's the default, and mostly because it works pretty well in most scenarios. Finally, super async, and this is the only synchronization mode available for any auxiliary standbys, so those standbys that are in a different data center. Those DR standbys, super async is currently the only mode available for those standbys. Super async, the commit comes in, it is written to log on the primary, and it is considered complete. So that looks exactly like it looks when we have no HADR involved at all. So super async is the only one where we have no risk of performance impact added by HADR. So this is a summary slide kind of going through these in the spectrum that we have on one side a very low chance of data loss with sync, and on the other side a very high risk of data loss. And on the other side we have no chance of performance impact with super async, and we have a high chance of performance impact with sync. So any questions on the synchronization modes? Uh-huh.
How is it coordinating when to restart from?
With super async, one doesn't know how to restart, where to restart from. So the servers still communicate. It's just not part of your commit processing, right? So they still communicate with each other where they are on the logs. You can look it up using Db2 PD or other monitoring methods. Does that make sense? I'm sorry, what was that? Not necessarily. From what I've seen situations where usually super ace. So for the primary or for keeping the servers close together? For the primary, yes. For the primary, absolutely. Super async is faster for the primary because it doesn't impact performance, right? Okay, so HADR database servers, when you're setting them up, you want to make sure that the servers are as identical as possible. Your operating systems may be at different levels for short periods of time, okay? So short periods of time usually means enough time to update the operating systems. We don't get an exact number as to they must be upgraded within a specific period of time, but it's not something where you want to upgrade the operating system or update the patches on the operating system on one side and leave it running for 6 months while you before you upgrade the other one. The file systems must be identical in most aspects. And the version of DB2 must be identical. So I get a lot of people who come to me and say, hey, Ember, can I use HADR failovers to do an online upgrade, to do a rolling upgrade of DB2? For version level upgrades, that is not true. You cannot use different versions. However, you can use different fix packs. So when you're applying a fix pack, you can do a rolling upgrade of DB2 with the fix packs. And specifically, the fix pack on the standby can be later than the primary for short periods. And if you're looking at an upgrade, come talk to me. I've got some thoughts on what the order looks like and what that looks like if you're working on it. Yeah, I don't have an exact timing. It should be as close for short periods. You know, there isn't a number. Yeah, Dale, do you have any thoughts on how long is safe?
There is no magic number. You just have to be careful with using TSAMP and RSCT and making sure that everything is in sync. So more of a challenge for AIX servers. We're part of TSAMP are the operating system, whereas with Linux it's a little more lenient because everything's bundled. So there is no magic number, but try to move it up.
Okay, so when I talk to clients about the various high availability and disaster recovery options, I tell them HADR is easy. It's something that's all within the skill set of a DBA. There's nothing too complicated. It's not something that's hard. Once you've done it even once, you realize that it's not difficult. These are the parameters that you're generally going to have to set in order to set up HADR. I'm not going to read through all of them. It's something that's easy to research and go through. I want to point a couple out here. The HADR sync mode, that's what we talked about as far as the decision that you need to make as far as what makes sense for your goals and your environment. These are obviously, in some ways, these are kind of the old way of setting things up. These are the values that are going to be used if this server is the primary, right? So if you have servers in multiple servers in the cluster, these are the values that are used if the server you're setting them on is the primary, right? So if you look here, the HADR target list is set. You're going to set that to all of the servers in the cluster as if this server is the primary, right? Okay, the time parameters are important to be aware of what they mean. There are two to be aware of. HADR timeout is something you have to be aware of in all HADR setups. It's the number of seconds before DB2 considers the two database servers disconnected. You generally want to have it be long enough to allow for short network glitches. The default is 120, and if you don't know anything else about your environment or anything, go ahead and stick with that. I've seen people have a very small number here when they have a very stable network environment. I've seen people where I've had to increase this a little bit for a very, very unstable network environment. So it's something to just keep in mind there. Now, HADR peer window is much more related to automatic failover. If you're going to be dealing with automatic failover, this is something that you have to be aware of. And what this is the seconds after HADR becomes disconnected. So it could be up to it doesn't even kick in until after HADR timeout in some cases, where DB2 still waits for an appropriate response from the standby before committing the transactions. So in a problem where you have an HADR a standby failure, your time to actually fail over using automatic failover could be the maximum of HADR timeout plus HADR peer window. So in this case, your HADR peer window, you want to make sure that's long enough to allow for the failure to be detected and for the failover to occur. With HADR peer window, 300 is a good starting point. I've seen this one very low as well in environments where the network is very stable and you have a quick failover. Yes? Right, so it really determines, there's some special syntax you use in the scripts that you might use for the failover, where you say takeover peer window by force peer window only. So it makes sure that you respect that peer window as part of those scripts. So it's not necessarily impacting what HADR itself is doing, but anything, even if you write your own scripts, you make sure that you respect that in those scripts. Okay, so do I need HADR in non-production environments? HADR is something that keeps things up and going. So it depends on, for one thing, what you consider production. I certainly have clients that have 24/7 development going on around the globe, and they consider development very critical. So it's possible that you may need to keep a development environment up for that kind of purpose. The number one environment where I would recommend having HADR in a non-production environment is in a load test environment. And the reason is that obviously HADR can impact your performance. So if you have a true load test environment, you want HADR in a similar kind of configuration that you have in production to make sure that there's not some impact from HADR that you're not accounting for in your load test environment. The other scenario that it's nice to have HADR for is for you as the DBA to be able to have a place to test your processes with HADR. What is my process for a fix pack with HADR? How do I go through that, right? That's something that can take some learning and to have some comfort with that before you go into production. If you only have it in production, then you don't have that kind of a test environment to play with and understand what's going on. Okay, so these are the biggest problems that I run into with HADR. Setup, typo, number one thing. I once spent probably 6 hours on a problem and ended up opening a PMR only to discover I had transposed a 1 and a 0 in an IP address, right? That is the number one place where you're going to have problems with HADR is if you make a mistake. So one of the first things I do if I have any problems with an HADR start is I go through bit by bit and look at everything, and then if it still looks the same, I go to a colleague and I say, hey, can you look at this and see what I'm missing, because I know there's something wrong here. Other issues with HADR setup, the network, there can be a firewall between servers. That happens sometimes. There can be other things that prevent the database servers from connecting over the ports that you're using. There can be host name issues. Make sure your host file is properly configured. Ongoing. Always check HADR status 5 minutes after you start it. And the main reason is sometimes you start HADR, everything, it said, hey, I started. You just can't assume that's correct. You need to go back and look at it because there are a lot of situations where HADR fails and goes down immediately after, and you need to troubleshoot and figure out what's going on there. Monitor HADR because it can go down silently to you. It can be something where the standby stops working, and DB2 doesn't stop the primary just because the standby stops working, because that would be kind of anti-high availability, right? Now I have 2 servers that I have to have up for DB2 to be running. Unsupported loads, that's a major problem. We'll talk about that a bit later. And non-logged actions. In my opinion, the database configuration parameter block non-logged should be set for every database environment. It's an online configurable variable, so if you're worried about it, it's really easy to back out a change to it or turn it off for a little bit or whatever you might need to do. So it's one that's low risk to be able to change. Complications, load, you need to teach your developers. If you're doing load in an HADR environment, they need to do copy yes on their loads, and they need to put it to a supported location. There is no combination of registry, environment, and database variables that you can set to force this to happen. You can set block non-log to make it so they don't do non-logged things. You can make it so that copy no redirects to copy yes. But if they say copy yes to some other location, then that's not a shared file system between your HADR servers, then there is no way you can force it so they can't do that. I've got an RFE open for that, so if you're interested in voting on it, let me know. I'll give you the number. Okay. I will give you the number after the session, or give you the link after the session, and you can vote on that too. It has, if you have replication or QRep, you may have to set it up on both or all HADR servers, so you're ready to fail over that processing as well. Your values stored, okay, so some databases store values that are server specific in some way, and this depends on what the database is used for. So there are some applications that need to be aware of that and may need to might have issues with that. Changes to server names and server IP addresses, you need to be aware of that and be ready to reconfigure HADR to support that. And problematic networks. I had a client who had a really problematic network, and whenever there was a problem with their network, they would also reboot both database servers at the same time. And I never quite understood why they were rebooting both database servers at the same time, but it definitely led to some interesting outages. Okay, so there are 3 tools available to help you with HADR. If you're considering implementing HADR, if you want to know the performance impact that HADR might have in your environment. And these tools, in general, do not require Db2 to be installed to be used. So they're very useful in going into a new environment and figuring out what HADR looks like, what impacts it might have, and some of these details. The HADR Simulator simulates HADR on 1 or 2 nodes. So if you have the 2 servers that you want to run HADR on set up, or 2 servers that are similar in different data centers that you want to understand what HADR would look like between those data centers, it's great for that. It measures disk speed, it measures network speed, and it also performs name resolution the same way that HADR would, which is useful. It's a binary executable, and because it's a binary executable, it's there for a bunch of different platforms. And the links to all of these are in the student notes if you want to go out. They're on a wiki that is supplied by IBM, so it's not a non-IBM set of tools, it's an IBM-supplied set of tools. The second of these 3 tools is called the Db2 Log Scanner. And what this one does is it scans through your transaction logs for a database. And this one doesn't even have to run on the database server. So if you're willing to transfer some database logs to some other server, you can install this tool on that server and analyze them somewhere else. So it scans through your transaction logs. And it will give you it gives you a lot of output that you really aren't going to use. You're mostly going to use the output from this to plug into the next step. But what it does is it looks at how much transactional volume you're seeing, so that it can do some calculations as to what modes of HADR might impact performance. There are 2 big problems. It only works for unencrypted databases. If you have an encrypted database, you can't use this tool. Also, if you have compressed, if you're using log archive log compression, you can't do it on the compressed tools. I've asked for the ability to use it on the others, and it's just not a high enough priority for them to get that moving. The HADR calculator just takes input from the last two tools and does some calculations. There's no need to run it on database servers. It's a Perl script called hadrcalculator.pl. And this is what that output looks like. When you run both of the previous tools, that takes into account the environment you're talking about HADR for, and it also takes into account the Db2 transactional volume for HADR. It'll give you output that looks like this, and it'll show you for each synchronization mode whether at this particular time performance would have been impacted. It'll give you either nothing, so performance would not be impacted in this particular time frame for any of them, or it'll give you 1, 2, or 3 question marks. If it gives you 3 question marks, stop. That's probably going to be a pretty big problem as far as performance goes for that synchronization mode. You can see in this example, it does show me a couple of question marks. When I was doing this test and playing with it to get this output, I actually had to tweak my network and disk settings way down from where they were in order to even get the question marks. So, it'll give it to you. It'll do it based on the numbers that you plug into it. I've got a great set of blog articles out there on these tools that'll walk you through. This is how to run this tool. This is what the output looks like. This is how you feed it into the other tool, and all the details on these. Okay, so automating takeover is the part that's not easy. So HADR is easy. Automating takeover is a little bit more difficult. It's included with most Db2 licenses. You have to be careful because there are some restricted licenses it's not included with. And depending on your version, it might not be included in workgroup as well. So make sure you look at the details and look in the Knowledge Center to understand whether TSAMP is included. The same work that TSAMP does for automating failover, you can build yourself in HACMP or Power HA, Linux HA, Red Hat clustering services, Microsoft clustering services. There's a number of different ways you can do it. If you're doing it in Microsoft clustering services, let me know. I know somebody I can connect you with who has done it and might be able to give you a few tips on the pain that he went through with that. And you can write your own scripts. That's a lot of what you're doing with some of these tools. With Power HA, I've done it once with Power HA. I wouldn't recommend it. It's not terribly fun. I would recommend just going with TSAMP. It's a supported way of doing it. It's much easier. When we're automating, we need a heartbeat. The idea with a heartbeat is that we want to detect if Db2 is down, and TSAMP will actually try to restart it locally first. And if it can't restart it locally, then it will go ahead and initiate a takeover situation. The takeover requires the HADR peer window to be properly set. If that's not properly set, you won't get a takeover. Ask me how I know. And the takeover has to be detected and acted on using the peer window only syntax for a forced takeover. Remember we talked about that with the HADR peer window. And generally, when you're talking about automating failover, you're only talking about automating failover for high availability. DR is a different thing. Usually with DR, we're failing over more than the database. There's usually an application aspect as well. So we don't usually automate the failover for DR. Automation of failover is for high availability only. So when you're going through the TSAMP setup process, you are going to have to first make some design decisions. You're going to have to set up HADR and then do some preparation work for TSAMP. We're going to set up TSAMP using Db2 Haiku, and then you're also going to test for failure scenarios. If you have HA and you haven't tested it, you don't have HA. So the decisions you have to make going in for TSAMP, you have to decide if you will use a virtual IP address for the database connection. Virtual IP makes it easy because then applications connect into that virtual IP. They don't care where that virtual IP lives, which server it is on. If you don't have a virtual IP address, then you have to have an application that will support automatic client reroute and an alternate server specified either in the application or via Db2's alternate client reroute facility. You will also need to know the subnet mask of that virtual IP address. You need to know what you will use for a network quorum device. Okay, so currently the only quorum device that is supported by the tools we use with Db2 Haiku is a network quorum. It sounds like in the next version they're probably coming up with support for a disk and a other node type of quorum device. So the quorum device is how it decides. Go ahead. Dale, is it available? 11.1.44. So yeah, the latest fix pack of 11.1. And so if you're using a network one, which was the only one available before 11.1.4.4, then you need a server that is very highly available, such as a domain controller or a default gateway. That's the best way. You need that server to always be available. And then you need to know if there is a private network between the two database servers that is used by a HADR. You're going to have to configure some network things in this that will define that private network as well as public network. So the required inputs that you have to have ready before you go into Db2 Haiku, you need the public IP address of both database servers. You need the fully qualified host names of both database servers, the IP address of the quorum device, and the names of the network cards associated and which networks they're associated with. And that may be something that you can figure out yourself, or it may be something that you need to ask a system administrator for. Optional is the virtual IP address, although I generally don't consider that optional. I generally assume that if you're doing this kind of failover, you want the virtual IP address. The private IP address, if one is being used on the private network, and the name of the network cards there. So I have detailed links on how to set up TSAMP here. We're not going through that in detail in this session. Add for the what? The kernel device? Yeah. Quorum. Oh, quorum. So the quorum device, what with the quorum device?
You're commanded to add that device to the server nodes of the cluster or leave it out of the cluster?
No, it's not part of the cluster. Right. Am I wrong, Dale? It is a third node? Okay, so... But the network quorum device, when it's a network quorum device, is that added in as a third node? Yeah, okay. Okay, pingable address, yeah. Okay, so now on to the fun part, real-world problems. These are things that I have actually seen happen in the real world. In each case, in most cases, they weren't my fault. But they are things that I have seen, and I hope that you can benefit from as well. So first, a quick explanation of what split brain means. Split brain means the network between the two database servers goes down, and in the worst case scenario, you have clients trying to connect into both of them, and they are both primary. This is not something IBM allows to happen very easily. I've heard of people who have seen it in the real world. I've never seen it in the real world myself. You had it? It's inevitable that somebody has seen it. So it can happen. It's a DBA's worst nightmare to some extent that both databases would be taking traffic at the same time, right? Because then you have data all changed in different ways, and how do you merge it back together? It's not a fun scenario to resolve. Okay, so in this particular environment, we had 4-server HADR. We had 2 HA database servers in one data center and 2 DR in another data center. This was on Db2 10.5. The environment was established. It had been up and running for at least 6 months. And they were doing some OS patching that required some reboots of both servers in the DR data center. That's why we were touching the environment at all. This is an environment where a client had brought me in an expert kind of role because they suspected their regular support staff from a generic consulting company did not have the skill set needed, and oh my God, they were correct. So there was a miscommunication on the part of that company, and I wasn't brought in until the problem was well in progress. So this is the diagram of the environment. We have the primary here in your HA data center. We have 2 standbys over here and 1 here in the primary data center. So here's what should have happened. We should have stopped HADR on and DB2 on these servers, or well, not even stopped, just deactivated the databases on these servers so that they could take the servers down and do the patching. And then they should have brought the servers back up after the OS patching was complete, and then activated the databases on these so that they were brought back into the HADR cluster. Here's what actually happened. They did a takeover. So they made node 3 here, the primary. This was a miscommunication in what was needed, or somebody started from the wrong runbook, or yeah, they manually said take over on this node. This is all manual. And then they shut down the servers. And then they went, wait, our site's down. What's going on? What's the issue here? And so this was outage number 1 when this occurred. It was 45 minutes. It was the middle of the night. And then they realized, okay, well, we can just start this one back up as primary. So they started this one back up as primary. There was no data that changed over here because the virtual IP address had not moved and nothing had connected over here, so they weren't worried about it. So the next issue happened. They brought these servers back up. They were easily able to bring this one back into the HADR cluster. And then they went to try to bring this one back in. They noticed it wasn't coming up with a normal syntax. So they said, hey, I'm going to start that one as primary. And at that point, DB2 had all the communication here, and DB2 went, no, you've got primary by force, by the way. It wasn't just yeah, there's the, so they forced it to be a primary. So DB2 went, I can't have 2 primaries. There was this really fun message in the DB2 diagnostic log that said, poison pill. So it was fun. And this is the point at which they called me. So this was outage number 2. It was a couple hours during the business day while I figured out, at the time I had no idea what was going on or why. So we were able to, at that point, we were able to bring the primary force a primary back to where it needed to be. But the client was panicked. They're like, if we bring DR up, prod's going down, right? That's the way the client interpreted what happened at this point. And so these servers were down for multiple days due to the fear that what happens if we start these servers back up. So we worked through that, and we got through to the point where we were finally able to bring those 2 back in. With a restore, this one had to be restored in order to bring it back in safely. So. Okay, so there's a text description of what should have happened here and what actually happened so that you can read through it if you want to review any of it. The moral of the story here is, number 1, define your procedures very well for less experienced DBAs. Because, yes, this wasn't part of my team in this case, but it was part of some senior DBA's team who didn't define very well exactly what needed to happen for this middle of the night change. Another thing here is when a mistake occurs, stop for a minute, take a breath, see if you can figure out what happened before trying to force something to happen. Because that could have been one outage and done, or it could have been no outages. Technically, it should have been no outages, but it could have been one outage in the middle of the night and done without all the other issues that occurred afterwards. Any questions about that one? Okay. So here's real-world problem number 2, non-logged loads. Okay, this was on DB2 10.5. It was actually a blue environment, 2-server HADR on a Pure App appliance. Pure App, blue, HADR, yeah. So block non-logged was set to yes. So it didn't allow non-logged operations. We had an NFS-mounted file system called Db2 Copy that was available on both the primary and the standby. The scripts are supposed to direct their copy yes location to Db2 Copy. And the registry variable db2 load copy no override was set to copy yes to db2 copy. So at the database level, I had done everything I could to make sure that these load copies went to the correct location. So this is generally what it looked like. We have a primary and a standby, same data center. There's a shared file system, and clients were coming in with a virtual IP address. The way I noticed this problem is on the standby, I started seeing these messages in the db2 diagnostic log. And I always change database names and IP addresses, but nothing else. Anything that would, all it would say is access not allowed with this weird message. And so I'm like, why are my diagnostic logs on my standbys growing so much? So I opened a PMR with, it was a PMR at the time, I opened a case with IBM support and got them to tell me what was happening. And they said, hey, these table spaces are in an unusable state. We've had loads with copy yeses that could not be replayed for these table spaces. And this was the only way that I had of noticing this in this particular situation. So the first thing I did was immediately restore each of those table spaces in a panic, going, okay, I have not been able to, had I had to do a failover, I would not have been able to access those tables in any way. The only thing I would have been able to do with those tables is drop them. So it was a scary situation to be in. And then I went out again to talk to the developers and the users to educate them on the appropriate locations for the copy file. And I also have a monitor now that parses the diagnostic log on the standby looking for these error messages. Now, I think IBM's getting a bit better with some of the messaging. This was on 10.5. But here's that RFE that I was talking about for getting it so that we can force a location for the copy yes and not run into this scenario at all. So if reads on standby are enabled, you can also identify this by using this SQL right here. That's part of any health check I do. When there are reads on standby enabled, I can easily identify any tables that have had this done that are in a non-available state on the standby. The moral of the story, educate developers and end users, monitor very thoroughly to verify what's going on. So trust but verify, teach them, but make sure you're double checking as well. Don't ignore messages in the diagnostic log that you don't understand. Make sure you're going out and seeing what they actually mean. All right, problem number 3, a cross-data center multi-standby performance problem. Okay, so this is actually a situation where we had a new implementation that was not configured by me. It was configured by the cheaper DBAs. And the cheaper DBAs had set it all up. It was brand new, and they were doing load tests against it before it went into production. Yay, load testing. And the way we had it is held down on the wrong button. There we go. Okay. So we have a primary server here and a principal standby here with a virtual IP address pointing to either one. And then in the DR data center, we had standbys there as well. And the load test in this case, the idea was that what should have happened, we were going to load test in DR and see what would happen when we load tested in DR. So we failed over to DR. This is what should have happened. The primary should have become this one, the principal standby this one, and the application should have been connecting in there. Which they were. That was not a problem. What actually happened in this scenario is the primary failed over here, and the principal standby stayed in the other data center. And that's the point at which they called me on the load test, because they were load testing against this server in the other data center, and they said, Ember, it's so slow. And this is NEARSYNC mode that is going across the data centers. And so that was the problem, is that they had the principal standby in the wrong place, and it was drastically slower. It was 2 to 3 times as much duration for a lot of the transactions. Dallas and Washington, D.C. You know, it's a very well-known hosting provider, so I was pretty surprised that it was as slow as it was. I haven't tested the actual network speed. It's fast enough to keep up in super async very closely. So.
We have an issue between Edmonton and Melbourne that's 300 kilometers per hour. Based on speed of light, it doesn't matter what net it is, 5 to 6 milliseconds.
Right. It should be. They should be within 100 kilometers of each other or less, preferably less, because of the speed of light, you know, physical limitations. So. Okay, so text explanations as well to go with it. The moral of this story is, number one, always test your takeovers. Number two is load test your takeovers whenever possible. If we had just functionally tested the takeovers to DR and not load tested them, we wouldn't have discovered this. This is the only client I have ever seen do load testing in DR. Functional testing, yes. Load testing, no. So it's very good that they did. And verify your configuration. If you have an expert DBA involved, maybe say, hey, could you verify this configuration for me? Yes?
Do you have the instructions of how you need to reestablish that primary standby in your DR?
So you don't have to do anything. The difference is in the configuration. So the HADR target list parameter was incorrect. So the HADR target list parameter needs to have the first server in it as what your principal standby is. And instead of having that one, it had a different one. It had what would be the principal standby for the primary and the other data center. Does that make sense? So. The virtual IP is not in DR at all. They had a separate set of applications they were using to test. So. Okay, one more real-world problem. We'll get through it as fast as we can here. We're almost out of time. Congestion. This is a 3-server HADR environment. We have 2 HA database servers in one data center and 1 DR database server in another data center. This is a Db2 11.1. All sync modes are super async. And the situation is that they brought me in to do a health check of HADR. I do a lot of health checks in environments, and they were having problems with HADR. They brought me in. They wanted me to look at it in detail. And in this particular case, they were collecting a lot of data. And so I took out and I graphed out some of their congestion and log gap. The yellow means that's time when there was a congestion. The red means that's time when there was a log gap. So this is standby number 1. This is the one in the same data center. This is the one in the other data center. And this is not good. We are not used to seeing this much yellow. We do not want to see this much yellow. And the red and blue lines, that indicates there's something slowing down HADR very significantly in these cases. So I had a meeting with them on September 16th. And I talked with their disk person and their network person in addition to the DBA and the manager people who had brought me in. And you know what? On the 19th, the problem went away. And it stayed away. If you do this graph to this day, it's a flat line. And the same here, except for with a couple of blips, you know. It's and I asked them. I said, "Hey, what's changed?" Oh, we didn't change anything. Nobody changed anything. That's the way it happens sometimes. The moral of the story here is don't be afraid to engage experts in other areas, right? Sometimes just knowing about the problem, sometimes those guys just hearing me going, okay, I'm going to be looking into disk, I'm going to be looking into network, I'm going to be digging into this, I'm going to be running the HADR Simulator, I'm going to, what I'm going to try, that was enough for somebody to go, oh, maybe I should check something, maybe I should fix something, I don't know what. To this day, I don't know what, and I'm still working with the same clients. So. That's all I have. I am